Most people think computer chips are made from sand. But between sand and the processor in your smartphone lies some of the most complex technology on Earth. Yes, everything really starts with sand. But not just any sand, it must contain a very high amount of silicon dioxide. Even then, this sand is completely useless for electronics. In sand, silicon is tightly bound to oxygen and cannot conduct electricity. It's just a chemical compound. To get silicon, the oxygen must be fully removed. How silicon is made from sand. At specialized factories, sand is heated to extremely high temperatures and chemically reduced. The result is technical-grade silicon with about 99% purity. But for chips, that is nowhere near enough. Even a single extra impurity atom can break a future transistor. Ultra-pure silicon is everything. So silicon is purified again and again. It's converted into a gas, then deposited back into solid form. This achieves purity levels of 99.99999% and higher. So-called semiconductor-grade silicon. It is one of the purest materials ever created by humans. From this silicon, a single crystal is grown, a massive cylinder where all atoms are perfectly aligned in one lattice. This process takes weeks and requires extreme control of temperature and vibrations. One tiny error and the entire crystal is scrapped. The finished crystal is sliced into ultra-thin wafers and polished until surface imperfections are measured in atoms. This is the physical foundation of a modern chip, building the processor layer by layer. Now multi-layer manufacturing begins. On the wafer, materials are deposited, removed, deposited again, hundreds of times. Each layer has a function. All layers together form a working processor. They create transistor channels, gates, insulation, and implant boron or phosphorus atoms to turn silicon into P-type or N-type material. Each layer is part of the chip circuit. And the key tool here is lithography. Older chips used DUV, deep ultraviolet light. But when transistors shrank to just a few nanometers, this light became too crude. It simply cannot draw such tiny features. That's a physical limit. EUV changes everything. The solution was EUV lithography, extreme ultraviolet light, with a wavelength of just 13.5 nanometers. This light cannot pass through lenses, cannot be focused like normal light news, is absorbed by almost everything, even air ren. That's why EUV machines operate in a vacuum. Instead of lenses, EUV uses mirrors. And this is where Zeiss comes in. Their mirrors reflect over 99% of EUV light, are shaped with precision better than the size of a single atom. If a mirror is off by even one atom, the chip fails. Without this optics, EUV doesn't work. 5 nanometers, 3 nanometers, and 2 nanometers chips are impossible. Mass-produced 2 nanometers chips don't exist yet, but the technology already does. And 3 nanometers chips are already inside Apple devices. That's why ASML's EUV machines cannot exist without Zeiss optics. A modern chip is not just silicon. It is ultra-pure chemistry, the physics of light, atomic-level optics, and technologies controlled by only a few companies on Earth. All of this, so you can hold a smartphone in your pocket and watch this video. What do you think about this? Write in the comments.